Hi guys, welcome to our fourth video of the Computer Lab session and for Dr. Brief class. In last video we covered a two-tail test, and in this video we're going to cover the right-tail test with two cases. First case will be having the null hypothesis with the hypothesized value equals to 0, and the second case with a non-zero hypothesized value. So let's start with the first one. In this case, we are going to test against whether to test whether IBM outperformed the market. In other words, the null hypothesis is going to be intercept smaller or equals to 0 and against the alternative hypothesis that the intercept is greater than 0. So as the test statistic for case 1 and 2 are the same, so I will not repeat it. I will simply use the same test statistic as the first argument of the p-norm function, and in case and just to recall, the p-norm is equal. You can use p-norm to compute the cumulative density functions. If you set the lower dot tail equals to true, but we set it lower dot tail equals to false because we want to compute the probability on the right tail. And providing the quantile, which is the in this case the test statistic we compute, and we can get the shaded area on the right hand side, and it's a right tail test, so we do not need to times 2. The p-value is going to be equals to 0.411, which means that assuming IBM really has no abnormal return, there are around 41.12% or chance that the test statistic from any random sample will be equal or larger than the test statistic computed from these samples, so which exceed the 5% of the significance level, and hence we cannot reject the null hypothesis that the intercept is smaller or equal to 0. In other words, we cannot conclude IBM outperformed the market. And you will yield the same result if you use the test statistic approach compared against the critical value. If you use the critical value approach, you're going to provide the quantile as the probability as the first argument. So since it is a one-side right-tail test, so it's going to be 95%, and you provide the degree of freedom of the as the second argument using the acuity functions, and then you compare against it. You will see that you cannot reject the null hypothesis as well, which yield the same conclusion. And now we're going to do a second right-tail test, but this time we're going to with a non-zero hypothesized value. We are going to test again whether IBM is aggressive asset. So essentially we are testing whether the null hypothesis that beta 2 is smaller or equals to 1 against the alternative hypothesis that beta 2 is greater than 1. And again, we can extract the recall that the regression result. The beta 2 is on the second row, right? So we put second row, and the coefficient estimate is the first column, and standard error is the second column. So yeah, and we set the hypothesized value equals to 1, and then we compute it. And yeah, just to print both the coefficient estimate, standard error, and also the test statistic, and then we can use the test statistic we just compute to get the shaded area on the right tail by setting the lower dot tail equals to false. Again, if you didn't set the lower dot tail equals to false, by default it's going to return the CDF, which is not what you want in this case. And basically this is already the p-value because we do not need to times 2. and you can see that like the p-value is going to be 45.79%, which we cannot reject the null hypothesis at 5% significance level. Yeah, so again, like you can uncomment this part. Yeah, you can yes, if you directly compare the test statistic against the critical value, then you can see that like you cannot reject the null hypothesis as well.